Hi, hello, good morning to everybody. This is Dr. Brahmayya, Associate Professor of Chemistry, Department of SNH, MLR Institute of Technology, Hyderabad. So today I am going to talk about the different mechanisms of the corrosion. So the overview of the today's presentation. Mechanisms of corrosion, liquid metal corrosion, corrosion by other gases. So here the oxidation mechanism of the corrosion. Oxidation mechanism of the corrosion. So generally in the air, oxygen will always be there as a 21%. So this air is also causing corrosion on the metal surfaces. How it is forming, we can see here. So if you look into this figure, this is a metal surface, this is a metal surface, this is a metal, and this is a oxygen. This is oxygen. When it is interacting with the surface of the metal, how the oxygen is reacting with the metal, we can see. So initially, when it is interacted with the surface of the metal, metal will lose its electrons. Metal will lose its electrons, and slowly it will form M2 plus ions. M2 plus ions, and this will react with oxygen. How it is reacting with oxygen, we can see. So the released electrons will form M gives rise to M2 plus and 2 electrons. 2 electrons are released here. These 2 electrons will react with oxygen. See here, half O2 gives rise to plus 2 electrons gives rise to O2 minus. This is the anion which is usually forms by interacting with the metal surface with the oxygen. Generally, oxygen accepts these electrons from the metal and changes to oxide ions, O2 minus ions. So then it will form M2 plus ions already formed here, and O2 minus ions already formed by gaining the electrons. This will form metal oxides. So this metal oxide will form, and the surface of the metal will be lost like this. The corrosion will be formed like this. So this is lost its ductility, malleability, conductivity. So this is the thing what happened by the rusting of the metal surface. This is the oxidation mechanism of the corrosion. Corrosion by other gases. For example, gases like SO2, CO2, Cl2, H2S, etc. induce action on metals in dry atmosphere, forming protective or non-protective layers. For example, see here, CO2, as usually, as we discussed in the earlier presentation, it will form with H2O, H2CO3, carbonic acid. So this carbonic acid will generally reduces the pH into the lowers to the below 7. So it makes the acidic nature. So acidic nature will generally form on the surface of the metals corrosion or corroded material. So like this is because of the carbonic acid, how the pipeline is lost its stability. So metal surface become like this. So it is losing its strength. And H2S is also forms iron sulfide. So this also causes the corrosion. And SO2, as usually, SO2 will gives rise to H2O, gives rise to H2SO3, and H2SO3 on further oxidation H2SO4. So these are the very dangerous chemicals. So because of these acidic chemicals, the metal surface will lose its stability or strength. So dry Cl2 reacts with silver and forms AgCl, protective layer, and stannous chloride forms volatile layer. So there are a protective layer and non-protective layers will be formed by the metals. Liquid metal corrosion. So this is due to the chemical action of the flowing liquid metal at a high temperature. This is a liquid metal corrosion. This is due to the chemical action of the flowing liquid metal at high temperature. The corrosion reaction involves the either dissolution of the solid metal by a liquid metal, or liquid metal may penetrate into the solid metal. So we have to understand the concept. Dissolution of the solid metal. The solid metal will be dissolved by a liquid metal, or liquid metal may be penetrate into the solid metal. So this is the way how the liquid metal corrosion will be formed. For example, mercury. Mercury is a liquid metal. Mercury forms amalgams with the metals and corroding them. So this is a liquid metal. So how it is mixed with, how it is penetrating into the metal surface. You look into this without any influence of the mercury. After its attack on the surface of this metal, how the metal surface was destroyed or destructed due to the formation of the amalgams of mercury. Wet corrosion or electrochemical corrosion. So this corrosion involves the flow of electrons between the anodic part and cathodic part of the same metal surface, or when two different metals are in contact with each other in the presence of a conducting medium. So it's nothing but a electrochemical cell, or it's nothing but a galvanic cell. So generally in electrochemistry we have been seeing many types of cells, electrochemical cells and galvanic cell. So how the anode and cathode will be involved in the chemical reactions, electrochemical reactions. We know very well about that one. So the flow of electrons between the anodic part and cathodic part of the same metal are in other two different metals, two different individual metals, or zinc or copper, for example, very common combination. So within the same metal or in two different metals, this corrosion will be generally forms due to the flow of electrons. The anodic reaction involves oxidation of the metal, forming metal ions with the liberation of the electrons. Anodic part, we know very well about that one. Anodic part will be form M2 plus or Mn plus ions plus n electrons or plus 2 electrons, whatever it is. So how many electrons lost with the metal, that will be appeared here, and the ions of the corresponding metal will be happened here, cations. The liberated electrons flow towards the cathode through electrolyte. So the released electrons will be forwarded to cathodic part via electrolytic by using the electrolyte. Electrolytic is nothing but copper sulfate solution or zinc sulfate solutions. General common electrolytes. So finally, metal ions liberated at the anode and some anions formed at the cathode diffuse towards each other through the electrolyte and form a corrosion product between the anode and cathode. So between the anode and cathode, we can see here, this is a iron metal and it loses its electrons. It loses its electrons Fe2 plus, and it will react with moisture. It will react with moisture like H2O. Then it forms Fe2O3 compound. So that is the rusting, that is the corrosion. It generally forms. So here iron acts as anode and this H plus ions will act as a taking the electrons. So this is the anodic part, this is the cathodic part. So like that, the instrument will be lost its stability. Mechanisms involved in the electrochemical corrosion. Based on the nature of the environment or electrolyte, there are the following mechanisms involved in the electrochemical corrosion. In acidic medium, hydrogen evolution mechanism, and neutral or alkaline medium, oxygen absorption mechanisms. So these are the mechanisms involved in the acidic medium or neutral or alkaline medium. So hydrogen evolution mechanism. So we can see it occurs in acidic medium like in industrial water and solution of non-oxidizing acids like a steel tank. Acidic industrial water is in contact with a small copper scrap. The piece of the copper and steel tank in contact with each other in presence of the acid electrolyte to form an electrochemical cell. In this process, steel acts as anode and copper acts as cathode. It is observed that the steel tank portion in contact with the piece of the copper is corroded. So here, this is the steel tank. Here, the copper strip is here. This is the electrolyte. Electrolyte means it's a industrial wastewater. Industrial wastewater is a mix-up of many chemicals like acidic medium, alkaline medium. So many chemicals are there. So that industrial water will be like act as an electrolyte, and then this iron tank will be act as an anode, and we will keep the copper strip. We will keep the copper strip here. It is like a cathode. So then the electrochemical cells reactions will be happen between this iron and this copper strip by using this electrolyte. So iron will lose its electrons Fe2 plus ions, and these two electrons will be gained by Cu. 2 plus ions will give rise to Cu. So these electrochemical reactions will be happen. This is the way it is forming hydrogen evolution. The mechanism we can see here. Corrosion reacts what happened actually. At anode, Fe will lose its electrons, and at cathode, H plus ions from the acidic solution or industrial wastewater accept the free electrons obtained from the oxidation of the iron, and H2 gas formed is liberated in the form of the bubbles at cathode. See, the 2H plus ions from the industrial wastewater will gain by 2 electrons, which forms H2 gas. Reduction. So net reaction is Fe plus 2H plus gives rise to Fe2 plus ions and H2 gas. This is the net reaction. This corrosion mechanism involves the displacement of the H plus ions from the acidic electrolyte by the metal ion and converting them to H2 gas at the cathode. Very simple. This is the reaction. These are the reactions. This corrosion mechanism involves a displacement of the H plus ions from the acidic electrolyte by the metal ion and converting them to H2 gas at cathode. This is very simple concept to understand. Summary. In summary, it is concluded that the presentation covers the different types of the corrosion mechanisms, how the oxidation corrosion mechanism happens and hydrogen evolution mechanism happen in the daily life was explained. Thank you.